This video is about rational functions. Okay, first of all, you remind yourself of what the rational function parent function looks like. And this is the equation, 1 over x. Rational function means it's a ratio, so it's a fraction. X is in the denominator. So if you recall, the rational function looks like this. So these lines approach the axes, but they don't cross it because there is a vertical asymptote and there is a horizontal asymptote which they do not cross. Okay? So the domain of this goes from negative infinity up until 0. Nothing's happening at 0 where x is 0, all the way to positive infinity. So there's a break in the graph. Range are the y values, remember, going from negative infinity, it breaks at 0, picks right back up on the other side of 0, and goes to positive infinity. Now the asymptotes, notice, happen where x is equal to 0 and where y The asymptotes happen where x is equal to 0 and where y is equal to 0. Those are basically your axes. On the parent function, that's where the asymptotes are. Now, remember what an asymptote is. Simply a straight line which the curve approaches. Okay, so the curve's going to approach it. If it is a vertical, up and down, the curve cannot cross it. So think of it as a concrete barrier. Curve cannot cross a vertical asymptote. However, if it's a horizontal, like a y equals, it can cross it. It doesn't always cross it, but it can cross it. So think of it more like a, you've seen the construction snow fences. They're plastic. Things can get through them, but it does create a barrier of some sort. So that's a horizontal. Verticals cannot be crossed. Horizontals can. Now, basic transformations happen on your rational equation or rational function as well. Remember, it basically looks like this. All right, with your asymptotes. Now, here, look at this. X is x plus 2. Remember, this is happening to the x, so it is a horizontal shift, left and right. This one, since it's a plus, is going left 2. So what normally was happening at 0, 0 is moving left 2. So here's my vertical asymptote, horizontal asymptote. So my graph is going to do this, but it moved left 2. You get the idea. Here, negative 1 over x. So this is a reflection. Now, the cool thing with rationals is it doesn't matter if it's a reflection over x or y, because either way you flip it, the graph is going to look the same. All right, so when you reflect it, the asymptotes stay the same, and it's going to flip. Okay, if I flipped it over x, it would look the same as if I flipped it over y. That's why we don't say specifically reflection over x or y. It's just a reflection. Now that's only for rational functions. Example 3 here, 1 over x, that's my rational, plus 2. That plus 2 is happening to the whole thing, so that means it's going up 2. So my asymptotes, this one's going to stay the same. My asymptote at 0 is going to move. So it's moving up 2. So there's where my horizontal asymptote will be. Vertical is not changing. Okay. And so it's just going to scooch my graph up 2. Remember, the line approaches the asymptotes, generally does not cross them.